Hello dear student, today we will continue chapter 4 about mechanical actions. Before we start, you need to prepare your stuff and follow these instructions. Objectives. At the end of this video, students will be able to identify the characteristic elements of a force, recognize the SI unit of a force. Prerequisites from the previous video. We learned before that a force, push or pull, is a mechanical action exerted by one object on another. If you observe this figure, the boy here is pushing the box while the boy here is pulling the box. Both are applying a force on this box. Effects of a force. The first effect we said before is it sets an object in motion. This object was initially at rest. Second one, it modifies the motion of an object. Third one, it modifies or deforms the shape of an object. Observe these three cases. The boy is exerting a force on the same box. Is this force the same in the three cases? What do you think? How can we know? To know if this force is the same or different, we should learn first how can we represent a force exerted by a body on another. Then we can see if this force is the same in the three cases or not. Representation of a force. We have in the figure here a girl whom pulling the teddy bear to her side and a boy that he's pulling the teddy bear to his side. Is this force the same? How can we represent it? Let's see. We can represent it by a vector. A force is represented by a vector. A vector is considered as an arrow. How can we draw this vector? What are the characteristic elements of a force vector? Let's take an example to learn those elements. We have in this figure a father who is pushing the stroller of his son. What is the first characteristic elements of a force vector? The first one is called the point of application. What is the point of application? The point of application is the point where the force is applied. Where is this father pushing the stroller? At which point? At this point here, where he put his hands. This is the point of application of a force vector. At this point, we should start drawing the vector. Second characteristic is the line of action. What is the line of action? It is the line along which the force is acting. What does this mean? Let's see. The line of action could be a vertical line, a horizontal line, or an oblique line. What is the line of action of the force exerted by the father on the stroller? What is the line of action here? What do you think? Is the father moving in a vertical line, or in a horizontal line, or an oblique line? What is the line of action of the force exerted by him? By a horizontal line. Very good. So the line of action of the force exerted by the father on the stroller is a horizontal line. Third characteristic, direction. What do we mean by the term direction? The sense of the force. Let's see, what are the senses of the force? Upward, downward, right direction, left direction, upward to the right, downward to the left, upward to the left, downward to the right. What do you think the direction of the action of the force exerted by the father? What is the direction of this force? Let's see here, according to this star, it is to the left. This green vector represents the characteristic elements of a force exerted by the father on the stroller. How? It shows the point of application at which the father exerting a force on the stroller. It starts from the point of application. It also shows the line of action of the force exerted by the father, which is horizontal. It also shows the direction, the left direction exerted by the force of the father. Does the length of a vector means anything? What do you think? Yes, of course. If bigger baby is put in a stroller, a greater force will be done by the father on the stroller to push it forward. So we should draw a longer arrow to represent this force. This is the fourth characteristic element of a force vector. It is called the magnitude. The magnitude, it's the intensity of the force. So, this arrow represents all, or this vector represents all the characteristic element of a force. It represents the point of application at which the force starts or is applied. It represents the line of action. It represents the direction of this force, and also it represents its length, represents the magnitude of this force. How we measure the magnitude of a force? The magnitude of a force is measured using a spring balance or dynamometer. Those are the spring balance or dynamometer. The magnitude of a force is expressed in Newton, simplified by the letter N, in the SI unit, after the scientist Isaac Newton. The SI unit always written on the spring balance or on the dynamometer. What if the dynamometer carries a scale? This is the dynamometer. This is the scale. To know the magnitude of the force, we should multiply the indication with the scale. What is the indication? It's the value shown on the dynamometer after applying a force on it. In this example, the magnitude is equal to the indication, which is 3.5 Newton, multiplied by 10, the scale, will be equal to 35 Newton. Open your booklet on worksheet 6. Fill the table below with the characteristics of a force. The four characteristics that we talked about were the point of application, the line of action, the direction, and the magnitude. Let's apply on the first case. First case, with my hand I pull the spring.
it becomes longer. It's said to be elongated. The force exerted by my hand on the end of the spring is represented by vector F. So we call this force exerted by my hand on the spring vector F. Then let's start. The vector name is F vector. What is the point of application exerted on the spring? It's point. Let's see on the figure. It's point. Oh, very good. What is the line of action? Is this line vertical line, horizontal line, or an oblique one? It's vertical. Very good. What is the direction exerted by this force? Is it upward direction? It's downward, to the left, to the right. What do you think? It's downward. What about the magnitude? How can we calculate it? To calculate the magnitude, we should use a ruler. We should take the length of the vector that we have from the point of application till the end of the vector. We should measure it by a ruler. Then we should use this scale. Each 1 centimeter gives 0.5 Newton. The length of this vector using the ruler is 1.6 centimeter. By using the multiplication between 1.6 multiplied by 0.5 divided by 1, we will have 0.8 Newton. So the magnitude exerted by this force on the spring is 0.8 Newton. Let's try with the second case. A hand is holding a book. What do we call the vector? The name of the vector is N vector. Always the vector have an arrow over it, over the letter. What is the point of application here? Observe the case. It is point S. The point of application is S. What is the line of action? The line of action, is it vertical? Is it a horizontal line? Is it an oblique one? What do you think? It is a vertical line. Very good. What about the direction? Is it upward, downward, to the right, to the left? What do you think? It is upward. The hand is holding a book, so it's upward. What about the magnitude? What should we do? We should take the length of the vector. We should measure it using a ruler, all of it from the point of application till the end of the vector. We should use the scale. So 1 centimeter will give us 5 Newton. Then we should write the length of the vector. Note that we should always pay attention to write the same units under each other. Centimeter under centimeter, Newton under Newton. So 2.8 centimeter multiplied by 0.5 divided by 1. It will be 1.4 Newton. So the force exerted by the hand on the book, its magnitude is 1.4 Newton. Third case. Pause the video for a few minutes. Try to apply the third and the fourth cases. Let's continue. The spring is compressed. With my hand, I push the spring, so it becomes shorter. It is said to be compressed. What is the vector name? Look at this case. It is T vector. Very good. What is the point of application? It is point I. What about the line of action? Is it vertical line, horizontal line, or an oblique one? It is vertical line. Is the direction upward, downward, or to the left or to the right? It is as shown upward. Very good. The magnitude, we should, using the ruler, take the length of the vector, and then using the scale we should calculate it. 1 centimeter give us 0.5 Newton, 1.4 centimeter the length of the vector, multiplied by 0.5 divided by 1. Note that we should always put the same units under each other. So the magnitude of this force is 0.7 Newton. Very good. Let's continue. Case 4. The man is opening the curtain. What do we call this? What is the name of this vector? It is called F vector prime. Very good. What is the point of application? It is point M. Line of action, vertical, horizontal, or an oblique? It is horizontal. Is the direction upward, downward, to the right, or to the left? The man is opening the curtain to the left, so the force exerted by the man on the curtain should be to the left. What about the magnitude? What should we do? Using the ruler, take the length of the vector, then using the scale, calculate it. 1 centimeter give us 0.5 Newton, 1.8 centimeter multiplied by 0.5 Newton divided by 1 equals 0.9 Newton. So magnitude of the force exerted by the man on the curtain is 0.9 Newton. Summary. Characteristics of a force. The 4 characteristics that we talked about is the point of application, the line of action, the direction, and the magnitude. Please solve part 4 in worksheet 6. Study the concept review page 46 in your book. Thank you.